Okay, great. So this is my talk. We're going to talk about forecasting over funnels. So how many of you worked with time series before, done that tutorial on forecasting, I don't know, hotel bookings in Australia, orange juice sales, and okay, yeah. So we're going to build on that a little bit. So I always like to tell people the main point first. So first is funnels are complex. We'll talk about what funnels are and why you should care. Next point, discrete time is not the same as time. And then we'll talk a little bit about how only looking at the bottom of the funnel can kind of screw you over. The way to fix that is don't leave data on the table. So this is a picture of a funnel. I'm not a great artist, but what is a revenue funnel? So this is how you think of a business process. So it's step one, locating people to buy your product and then qualifying them, and then other steps in the middle and profit. So this applies to a lot of different kinds of companies. So it could be online advertising, it could be selling cars, it could be underpants gnomes, whatever. So what I want you to think about is like Soylent Green. So the people are going to go at the top, your customers, and then dollars are going to pop out the bottom. So that's your revenue funnel. And so I kind of always, as a data scientist, try to break things down into equations. So is anyone from Google here? No? Okay, so I wanted to use the Greek letters to make this more sciencey, but the marker font does not actually have them, so we're stuck with the regular ones. But my formula for you all is R equals VCP. So your revenue equals your volume times your conversion rate times your price. Is that not too controversial? Okay. So I think most businesses have these things. Sometimes you think about your number of sales. You can actually think of your number of sales. Well, that's your volume times your conversion rate. Or maybe you think about your revenue per customer. That's the conversion rate times the price. So you can move the symbols around and do your algebra one and solve one based on any of the others. But this is a talk about time series. So math. How do we make things over time? Yeah, you stick T's on subscripts on the bottom of all of them. That's it, right? So does your revenue over time actually equal volume for that time period times your conversion for that period times your price for that time period? In my experience, discrete time is not actually time. So this is kind of an example. So if we have a funnel with people at the top, we've got the cold people, they warm up and then they convert or not. Maybe the cold people, sometimes they convert in one day, sometimes they warm up in a different day, and then it takes 3 days, and then they don't do anything. So this is more representative of kind of the real world. But if we were to bucket this into the days, and talk about sales, like it's just 1, 0, 1, 1, 0, right? Like that's ignoring a lot of other stuff on that picture, and we'll talk about that. And so then there's the other standard disclaimer is that time is tricky. So there's the traditional time series stuff that you're going to learn in most tutorials. So that'll be your seasonality, your trend, shocks, stuff like that. Also, you might learn about cohort effects if you're coming from disciplines that look at that. Most of these things also have the all things equal assumption. We'll talk about maybe if that's a bad idea or might not hold. So I'm going to work through an example. My examples always kind of go through the same process. So first we're going to start with a prompt, right? And we're going to draw a picture, look at some sample data, do some crosstabs, that kind of thing. Then we'll try something simple, and then we'll see how it does. So here's our prompt. So imagine a very, very simple business. It's a single product company. They have some digital good, I don't know, an ebook or trading card, I don't know, single product company. This simplifies it down because there's one product, there's only one price. We can ignore that last part of the equation. Just look at sales. So you got your landing page, people go to it, maybe they buy it. But for the ones that don't, they can sign up for your newsletter, which means they're going to get some emails saying that you should really buy my thing. But to simplify it, so let's say there's just a 4-wave drip campaign. So what that means is the people that sign up, they're going to get an email. If they buy it, that's cool. If they don't, they're going to get another email, and we'll do that 4 times. All following me so far? All right, so what if we were to draw a picture? And this took me quite a while in Google Slides. All right, so I think this is every possible thing that can happen based on what we just said. So people come in the top. That's kind of our funnel going down the diagonal. So the traffic, they can bounce, not do anything, or they can convert and we get $1, or they can sign up to our newsletter, and then they're in the purple, they're in the drip. And every day they're going to get another email, and they get another chance for that stuff to happen. People buy that? Did I leave anything out? You gotta challenge me on these things. This makes me go too fast. Okay, so if I were to convert that back into an equation, so what we have is our sales is our volume times the conversion rate for the basic traffic plus the people that sign up for the email times their conversion rate plus the people that make it into the second trip times their conversion rate, and so on. So far, so good? Okay, so we got an equation. What are the two things that we do if we're data scientists? You take the derivative and set it to 0, or you do a Taylor expansion. But we're not going to do that. So if we have something like this, we're going to start with crosstabs. So start with crosstabs. So same kind of thing you can imagine it is, all those dots in the earlier thing. So we're looking at our drip and which ones are selling or not, and then we've got our total sales over time. Is this big enough? Can you guys kind of see it? Or I don't know. Anyway, it just kind of jitters up and down. If you squint at it, it looks a little sticky, but it's pretty noisy. You know what I mean when I say sticky? Like it means it's kind of auto-correlated. Well, that's a big hint. Right. So let's aggregate that data so we can look at for each day. We've got this many people in each of the drips, and that's our total sales. So, all right. So we got our data aggregated. It's super nice and clean. What are we going to do? Because we've all had our time series tutorial, right? Right, so we're going to load up the forecast package by Bob. It's fantastic. We're going to drop our sales through auto.arima. Okay. Well, that didn't work, so it's just going straight through. So even though it grid searched like all 50 combinations of parameters, it decided that the flat line was actually the best. So that's not exactly what we wanted. So we'll look to do something a little more higher powered. So we'll be very briefly introducing the VAR model. So the reason that auto.arima kind of sucked was it was only looking at the sales. We weren't telling it what was happening up the funnel. So instead, we can use a model that does do that. So we're going to model our entire funnel as a vector using your regular autoregressive process, only instead of single numbers, now they're vectors. Instead of a vector of coefficients, we've got a matrix of coefficients. And kind of the slick thing about this is that now our conversion and bounce rates are sucked inside of this A guy right here. And we'll be using the vars package, which is quite nice. So drop our data through there. Hey, it's actually tracking. Awesome. So I'm happier with this than I was about AutoArima just giving me a straight line. Like I could make a straight line without all that effort. But this is actually tracking. So people, okay, keep going. So let's look at that matrix of coefficients. I have color coded the things that corresponded to our funnel. So we can see the people that are in our traffic bucket, 60% go into the second, got 90% not unsubscribing for each of the drips. And then our total sales are mainly being composed of the direct, and a lot of them are being composed by the people that make it all the way. That's kind of by construction because this is not real data, right? But you get a lot of stuff for free for one line of R. It's literally VAR data. You get this. It's fantastic. So what's actually going on under the hood? Under the hood, it's actually fitting a simple model for every part of your funnel, and we can look at how well each of those steps is doing. So we can this is a plot of R squared. You can choose whatever metric you like, really. R squared is nice because it goes 0 to 1, so it makes your bar plots easy. So modeling our total traffic, we're doing really bad. We got an R squared of, I don't know, 0.05. Once we're in the funnel, we're doing fantastic, right? R squareds of like 90, 95, great. Total sales, we know by construction, is a combination of our direct sales and then the people coming out of the drip emails. So somewhere in the middle, makes sense. Made sense to me anyway. Did people buy it? Okay. So then what happens when we do our actual forecast? So we don't get a straight line, but it does get straight towards the end. But we got a little bit of jiggle in the front, and the reason is we're iterating this. I mean, this happens with a lot of forecasts that don't have like strong seasonality components in there. So I'm going to loop back around. You all weren't arguing with me as much as I expected, but that's okay. So funnels are complex. Do people buy that? It's a lot of stuff can happen inside them. Discrete time is not the same as time. Okay. Only looking at sales, caveat emptor. If you just go for auto.arima, it may or may not work. If you're doing orange juice, you're probably going to be okay. If you're doing, I don't know, weird web stuff, maybe not. So you don't want to leave data on the table. If you do have that funnel data, then definitely take advantage of it. So then I'll flip it over to questions. All right. If you've got a question, just say your name and company or whatever, so I can get to know you all. Or I wrote my own. Okay, so who am I? So I'm a stats data ML consultant. That's my email address. I'm also an open source contributor on GitHub, and I'm a general opinion haver. Can ask my opinion about stuff. I will be reasonably honest. I'm not being recorded, am I? Well, okay, so what else is coming up in the LA area? So there's a bunch of stuff. I'm probably going to go to a lot of these. There's an Ideas conference where I'm talking about working with the city of Los Angeles for looking at the 911 call logs. I'll be there. PyData LA conference in December. I'm on the program committee. So our CFP is up. If you're interested in giving a talk, can send it in our abstract. Also, we need volunteers, so hit me up if that's anyone. Yes.
What is your favorite project you worked on?
Sorry, well, could you?
Is there any favorite project that you worked on being a
Oh,
consultant?
I mean, so I've done a lot of consulting over the years, and so the animal ones are always my favorites, as they tend to be pretty colorful. So, I mean, pick an animal. Okay, birds. So we'll say birds. So there was one guy I was working with, and he had gone out into the forest, and he had all these like tape recorders everywhere to record what the birds were saying to each other, and so he had some like pretty cool results there because like they're talking to each other. Your null hypothesis is that the birds are just random, so he was able to reject that one anyway. So that was a fun one. Dolphins were also interesting. Monkeys, yeah. Yeah. Yeah.
Is there like an automated way to choose the P component for the background regression? Like kind of like an auto-reader does, or do you have to go through that?
Yeah, so in the real world, you're going to have to do your due diligence. In example world, you know that it's one.
Okay.
Yeah. But yeah, all your same, model summary statistics are still on the table. So AIC, BIC, everyone's got their favorite. Yours will work with it. Yeah.
Yes, so I have a follow-up question that also talking about. So I'm just wondering if we have like traditional way to time series modeling, like to analyze time series data. Versus now we have like machine learning and just the APIs you can use to make Python with the R. Like just based on your experience, you think like which way works better, or is really based on like
Yeah, so I've been, yeah, so the question was asking if there was, and I'm going to paraphrase, so correct me if I'm wrong, is what's my experience been with using more sophisticated ML models compared to simpler time series stuff? I would say you can be successful with the fancier stuff, but because everything is changing over time, it's a little bit more complicated, so that means you need to be retraining a lot. What happens is if you know there's drift in the population, ML models are going to be more sensitive to that, and you have to be careful, versus like the old school time series stuff. It's like that noise is built into the model. It's like part of the probability model, and it can try and separate it out directly. Yeah. Yeah.
The NAND package is bar.
Bars with an S. Yeah.
Is there like a Python?
Ooh, good question. Almost certainly. So vector autoregression is like a textbook method. So if you go read Woolridge, it'll get like half a chapter. Very classic method. I feel like a lot of the time series stuff as it's taught, you just get your one time series, but the real fun's in the multivariate. So So I wanted to show it off a little bit. Other questions? I'm running out of my own. So extensions. So what if your volume is dependent? So what if your volume depended on a bid price for ads or your ad budget, for example? It's a great question. What if not all people are paying the same price? There's promo conditions there, and that affects your conversion rate. Also a fantastic question. What if there is an infinity drip? What if you keep going after 4? Also a great question. So I'm gonna leave that as an exercise to the reader, or I am available as a consultant. Either way. Yeah. Yeah, so because that could be an extension, but I know you, so we'll go ahead and field that. So the thing that's important about time is that it is a continuous flow, and so you want to take advantage of that. I would really recommend like a kernel method or something like that to fill in the middle, versus like don't fill in zeros, So leverage time. Also, a lot of these things you can do kind of a EM style thing, fit it, get the predictions out and plug them back in and iterate until it converges. So that's definitely on the table too. Whether it worked well or not would kind of probably really depend on the problem. Okay, so what exactly was the example? Here's the R code I used to generate that. It's using the Fabricate package that was written by Graham Blair and Aaron Rudkin and myself over at UCLA in the poli-sci department. If you find yourself needing to do a bunch of weird, generate synthetic data, this is a pretty nice package for that. Anything else? Okay, so why did that forecast actually flatten out? So this is the real answer to that. Someone was supposed to ask. So let's go back to our coefficients
Why
here.
did the forecast?
We'll put on our thinking hats here. So ignore the constant row. That's not really part of the model. And think of this thing as a matrix. So, what's the one thing that we always do with matrices as statisticians? We factor them. So if we look at the eigenvalues for this guy, the dominant eigenvalue is less than 1. So as we iteratively do our forecast, it's going to go down and down and down and converge to the mean. So that's what's going on with that. So there you go. Any other questions? Yeah.
When would you favor a farm model over current
neural So I think, and I mean, there's like a lot of different architectures for neural networks, but the big difference between using a VAR model and using a neural network is going to be that the neural networks have activation functions in the middle, versus this is pretty much just straight matrix multiply. So if that activation function is helpful, it's going to help, and if the activation function is not contributing very much, it's probably going to send your predictions in the wrong direction. That would be my intuition, right? And that's a fantastic question. You win. So since I am giving a talk at the Ideas Conference, they said I could have 5 free tickets to hand out, so you get one. And so yeah, that's literally all I have. Are there any other questions? All right. Yeah, Mia.
I know, but I'm just always curious what does the njnm mean?
It doesn't mean anything. I got it because the domain was available. You know how hard it is to get a domain with 4 letters? Yeah. So yeah. Thank you. All right. Thank you all very much.
Thank you so much, Neal. Again, thank you everybody for coming to Customer Data Science. Let's give another warm round of applause for Neal and Ahmad for talking today. So that's the end of our presentation section, but please stick around. We still have plenty of pizza, plenty of drinks, and some meet more people. I'm sure Ahmad and Neal will be in the back to answer any more questions you have. Again, thank you so much for coming. Oh, yes, so great question, man in the back. So the next Customer Data Science group meets the last Wednesday of every month, so that's going to be September 25th. Mark on your calendars. Also, we have a Slack group, which you should join to get more updates. I've been trying to post papers I'm reading. Happy to build that community there. Yeah, I think those are, again, I can answer any questions you have about the group. If it's your first time, come say hi to me. But yeah, again, thank you so much for coming. Hope you have a great time.